Hi, we're here with the team from Hyundai Research and their exoskeleton. It's pretty interesting because it helps disabled people get around. Can you tell us a little bit about the actuators we have here in the exoskeleton?
Yeah, this exoskeleton is actually for the elderly people. So this is one lineup among the exoskeleton we have. And this exoskeleton has really unique actuators. So it's actually the same structure applied to each actuator. So this actuator has electric motor and harmonic drives. And between electric motor and harmonic drives, there is one rubber belt. So if the wearer want to move, this guy move the gear and then rubber belt and electric motor. So this robot recognize the formation of rubber belt, and then this robot can know how the wearer want to move. So that's the basic under the theory of this robot. And then its augment the wearer's force. Also, along the vertical axis, this robot resists. So he cannot fall down actually. So by using this kind of generation of the torque at each joint, this robot can help the elderly people.
Can you point out there's 4 actuators on each side. Could you point those out for us?
Yeah, this has 4 joints, but actually various configuration can be applied to this kind of exoskeleton. So one product we made has 8 actuator, 10 actuator, 2 actuator, 1 actuator. So for the wearer's convenience or wearer's injured, we can apply various configuration of the actuator. So number of actuator is one of selection the wearer can want. Right.
What's the rating on the electric motors?
So the rating of the electric motor is 200 watt, but we can increase the power of the motor, or we can decrease the power of the motor. Everything is just depends on the injury degree of the wearer or the age of the elderly people. Yeah.
What's the ratio for the harmonic drive?
The harmonic drive ratio is very, very sensitive question because it depends on the ratio of the harmonic drive. The performance of the robot will be decided actually. That's a kind of secret of our institute. Sorry about that.
So you developed the drive and the motor in-house, or was any of it purchased?
Actually, right now we just use the commercial motor, but we have a plan to make our motor. Actually, we worked with a lot of university at Korea, so we will have our unique motor soon.
Good. And there's an electronic packs on his back. Can you show that? What are the connections that we see here?
Actually, all the power is applied through these lines, and then this one has some motor driver and controller and battery regulator, it's battery managing system. So this whole pack is really compact, so it's really challenging to put all the device into this small volume.
Gotcha.
But so we just try to minimize the battery pack and motor driver and then everything device. So the compactness is very important for this kind of exoskeleton. Yeah.
What's the battery capacity and the chemistry?
So battery capacity, he will explain.
The battery capacity it depends on the kind of wearable, but in this case, it plays 5,000 milliampere hour. Yeah.
Lithium ion?
Yeah.
Okay. Good. What's the next step?
So we have a plan to make the kind of final product for the patient, and then we will have a lot of experiment with the patient. So that's our plan to be done in 1 month. And then after that, we will have a walk with the doctors and patients and a lot of government officers. And then if we get some permission to make a really final product in the market, so we will have some enterprising about that. Yeah.
Great. That's an interesting development. Thank you very much.
Thank you.
Thank you.